Welcome to our lecture online. Just to give us some more practice on how to find the shortest distance between two lines in space, and to show you an interesting example, here we're going to do it where two lines actually cross. In other words, there's a point of intersection between the two lines, which means that the distance should be 0. Well, let's say we didn't know that. And here are the equations of the two lines that we worked with previously, so we kind of knew that they crossed and that the distance should be 0, but let's just simply work it out in the same way like we did before. So that means that step A is we need to find a vector that's perpendicular to the two lines, which means we first need to find the two parallel vectors, vector 1 and vector 2. So vector 1, which is parallel to line 1, is going to be equal to, notice that the denominators, when we have the equation in the general format, the denominators are the components of the parallel vector. So that's going to be 2i plus 1j plus 3k. And for the second vector, vector 2, the denominator is again going to be the component, so it's minus, oh, not minus, that's a positive. So it's going to be a little messy here. So it's going to be 1i, but there it's minus 2j and minus 1k. There we go. So there's the two vectors. Vector 1 is parallel to line 1, vector 2 is parallel to line 2. Now to get a vector that's perpendicular to both, we're going to take the cross product. So therefore A, which is equal to the cross product of vector 1 and vector 2, is going to be equal to, using the matrix format, I, j, k. Then we put in the components of vector 1, 2, 1, 3, the components of vector 2, 1, negative 2, negative 1, and let's work this out. So this is equal to I times 1 times negative 1, that's negative 1, minus negative 2 times 3, that's a plus 6, minus j times 2 times negative 1, that's negative 2, and minus 1 times 3, like this, and then plus k, and we have 2 times the negative 2, which is the negative 4, minus 1 times 1. All right, so simplifying that, we have our A vector. We get the A vector is equal to, that would be 5 in the I direction, minus 5 times a minus, that's plus 5 in the J direction, and minus 5 in the K direction. There we go. And then to find the magnitude of that vector, take the magnitude of vector A, that would be equal to the square root of, that would be 5 squared plus 5 squared plus, well, since it's squared, we'll just take the positive value of this. And so that would be equal to 5 times the square root of 3. And so here we have vector A and the magnitude of vector A. Now we need vector B. Vector B will connect 2 points on the two lines. So vector B can be found by taking, well, let's see here. First, let's find the points. That makes it a little bit easier. So point 1. Point 1 is equal to, well, that would be 2, 8, and 10 for the coordinates. So it would be 2, 8, and 10. And for point 2, that would be equal to 6, 10, and 16. 6, 10, and 16. So vector B will connect those 2 points. So we'll take point 2 minus point 1. So vector B will be equal to 6 minus 2 in the I direction, plus 10 minus 8 in the J direction, and then plus 16 minus 10 in the K direction. So simplifying that, we get B is equal to 4 in the I direction, plus 2 in the J direction, plus 6 in the K direction. And now we have both vectors A and B and the magnitude of A, so now we can find the distance. And again, since the line cross, they should be equal to 0. So let's try. D is equal to B dot A divided by the magnitude of A. All right, so we're going to multiply each component, x component of B times x component of A. So that's going to be 4 times 5 plus the y component times the y component, 2 times 5 plus z component times z component, 6 times a negative 5, the whole thing divided by the magnitude of A, which is 5 times the square root of 3. So this is equal to 20 plus 10 minus 30 divided by 5 times the square root of 3. And of course, when you look at the numerator, it's 30 minus 30, which is 0. the distance is 0, and that's what we expected to find because the two lines cross, and that's the shortest distance between two lines that cross. And it looks like our method does indeed work. That is how it's done.
That's no proof, no.
No, no proof.
Just,
Demonstration.